The morning sun cast long shadows across the university campus as Dr. Elena Reeves hurried toward the administrative building. Her heart pounded against her ribs, not from the brisk walk but from the gravity of what she was about to propose. After 15 years in forensic anthropology, she knew this could either define her career or end it completely. The hallway to the conference room seemed longer than usual. Elena clutched her presentation folder tighter, feeling the weight of the research papers inside, years of preliminary studies that had led to this moment. As she approached the heavy wooden door, she took a deep breath, squared her shoulders, and walked in. 12 pairs of eyes turned to look at her. The ethics committee members sat around a large oval table, their expressions ranging from curiosity to open skepticism. Professor Richard Chen, the committee chair, nodded at her to begin. "Thank you for meeting today," Elena started, her voice steadier than she felt. "As outlined in my proposal, I'm requesting approval for what I believe will be groundbreaking research in the field of forensic science." She moved to the projector, clicked through to her first slide, and faced the committee squarely. "We understand a great deal about life, but the physical process of death remains surprisingly understudied in real-time conditions." Professor Chen leaned forward slightly. "Dr. Reeves, we've reviewed your preliminary proposal. You're suggesting placing cameras inside coffins with human remains. Many of us have concerns." Elena had expected this. "I understand your hesitation, but this isn't about sensationalism. This is about science." She clicked to the next slide showing decomposition timelines. "Our current models of decomposition are based on external observations or lab simulations. But what actually happens in burial conditions moment by moment? The data could revolutionize forensic timelines in criminal cases, improve our understanding of environmental impacts, and even advance medical science." Dr. Olivia Thompson, a bioethicist on the committee, removed her glasses. "And the subjects? How do you propose to handle consent?" "We've partnered with the university hospital's donor program," Elena explained. "We've identified 3 individuals who are already planning to donate their bodies to science, and who have given explicit written consent for this specific research after extensive consultation. Their families have also been fully briefed and have given secondary consent." The room fell silent for a moment before Professor Chen spoke again. "Tell us about the technology. How would this actually work?" Elena nodded to her research assistant, Raj Patel, who stood up from his seat at the back of the room. Raj approached with a small metal case, which he placed on the table and opened. "This is our prototype," Elena said. "We've developed a specialized camera system that can function for up to 18 months on its internal power supply. It's completely sealed against environmental factors and uses infrared and low-light imaging. The camera transmits encrypted data to a secure server through a proprietary radio frequency that won't interfere with cemetery operations or nearby electronics." Dr. William Foster, the committee's legal consultant, frowned. "And you're certain this violates no cemetery regulations or local ordinances?" "We've secured preliminary approval from Green Meadows Cemetery for a controlled research plot, provided we receive university ethics approval," Elena confirmed. "All relevant legal documentation is included in Section 4 of your packets." For the next hour, Elena fielded increasingly specific questions from the committee. The discussion grew heated at times, particularly when Dr. Gregory Harris, a religious studies professor on the committee, raised concerns about dignity and respect for the deceased. "The camera doesn't disturb the remains in any way," Elena assured him, "and we've designed strict protocols for handling any unexpected observations with the utmost respect." As the meeting stretched into its second hour, Elena began to sense the committee's initial resistance softening into genuine scientific curiosity. Professor Chen's questions shifted from, "Why should this be done?" to, "How will you ensure proper data collection?" Finally, after nearly 3 hours, Professor Chen called for a preliminary vote. Elena and Raj were asked to step outside while the committee deliberated. The hallway felt too quiet after the intensity of the meeting. Elena paced while Raj leaned against the wall, both too anxious to speak. 20 minutes later, which felt like hours, They were called back in. Professor, Chen's expression gave nothing away. Dr. Reeves, the committee has reached a decision. While several members still have reservations, we recognize the scientific merit of your proposal. We're granting provisional approval subject to the following conditions. Elena felt her knees weaken slightly with relief as she listened to the list of additional safeguards and documentation requirements. They would need to implement enhanced data security, provide monthly reports, and allow a committee member to observe key stages of the research. Thank you, she said when Professor Chen finished. We won't let you down. 2 weeks later, Elena stood in her lab, surrounded by her small research team. Besides Raj, there was Dr. Lisa Nakamura, a microbiologist who specialized in decomposition processes, and Tom Wilson, their technology expert who had designed the camera systems. The modified cameras are ready, Tom said, showing them the sleek, capsule-shaped devices that would soon be gathering unprecedented data. I've tripled the battery capacity and added additional environmental sensors as the committee requested. Lisa looked up from her computer. I've finalized the baseline microbial analysis protocols. We'll be able to correlate any visual changes with specific biological activity. Elena nodded, feeling a mixture of scientific excitement and profound responsibility. Our first participant's family confirmed yesterday. Mr. David Chen passed away from natural causes at 86. He was a biology teacher for 40 years and specifically requested to be part of our research when he signed up for the body donation program last year. The team grew quiet, acknowledging the weight of what they were about to do. His funeral is tomorrow, Elena continued. His family has requested a traditional service, after which we'll implement our protocols. The following afternoon, under a cloudy sky that threatened rain, Elena and Raj stood respectfully at the back of the gathering at Green Meadows Cemetery. Nearly 100 people had come to say goodbye to David Chen. Former students, colleagues, and family members shared stories of his kindness, his passion for teaching, and his unfailing curiosity about the natural world. His daughter Lynn approached Elena after the main service. Dad would be so pleased to be continuing to teach even now, she said, wiping away tears. He believes so strongly in advancing science. We'll honor his contribution, Elena promised, and we'll keep you updated as the research progresses, just as we discussed. After the mourners departed, the cemetery staff gave Elena and her team access to the specially designated research area. With careful precision and solemn respect, they positioned the first of their camera systems according to the approved protocols. Back in her office that evening, Elena sat alone, watching as the first data began to appear on her monitor. The camera was functioning perfectly, sending back clear images and environmental readings from its position. What had started as a controversial idea was now a reality. She opened her research journal and began to write. Day 1. Project Transition. Officially initiated. First subject installed with full protocols observed. Initial readings normal and consistent with baseline predictions. Whatever we discover in the coming months, we've already achieved something significant. We've opened a window into a process that has remained largely hidden from scientific observation. Mr. Chen's final contribution to science has begun. Elena couldn't know then what the cameras would eventually reveal. She couldn't anticipate how this research would challenge fundamental assumptions about what happens after death. But as she looked at the first incoming data points, she felt a shiver of anticipation. They were about to witness something no one had ever properly documented before. The scientific journey had begun, and it would lead to places none of them could possibly imagine. 3 months passed like a blur for Elena and her team. What had begun as a controversial experiment had settled into a rhythm of daily data collection and analysis. The lab had become their second home, with coffee mugs scattered among stacks of printouts and multiple screens displaying the continuous feed from their cameras. It was a rainy Tuesday morning when Elena first noticed something odd in the readings. She had been reviewing the overnight data, a task she performed each morning before the rest of the team arrived. The temperature readings from Mr. Chen's monitoring equipment showed slight but consistent fluctuations that didn't match the expected pattern of decomposition. Elena frowned at her screen, took a sip of her now cold coffee, and pulled up the historical data for comparison. The pattern was subtle. A drop of exactly 0.3 degrees Celsius at the same time each night for the past week, lasting precisely 17 minutes before returning to the baseline. That's not right, she murmured to herself, checking the equipment specifications. Again, the temperature sensors were accurate to within 0.1 degrees, and this pattern was too consistent to be a malfunction. The door to the lab swung open as Raj arrived, shaking water from his umbrella. "Morning," he called, hanging his wet coat on the rack. "Anything interesting in the overnight data?" Elena motioned him over. "Look at this temperature pattern from Subject 1. "Have you ever seen anything like it?" Raj leaned in, pushing his glasses up his nose as he studied the screen. "That's weird. It's too regular to be natural decomposition. Could be sensor drift, but—" He trailed off, rubbing his chin. "Let me check the other sensors in the array." They spent the next hour pulling up every piece of data from Mr. Chen's monitoring system. What they found left them both puzzled and increasingly excited. It wasn't just the temperature fluctuations. The electromagnetic field sensors were picking up faint but measurable pulses that coincided perfectly with the temperature drops. "We need to check the visual feed during these events," Elena said, already pulling up the archived footage from the nights in question. The low-light camera had been functioning perfectly, providing clear infrared images of the decomposition process. Elena fast-forwarded to the timestamp of the previous night's anomaly. As the digital counter hit 2:17 a.m., both researchers leaned closer to the screen. At first, nothing seemed unusual. Then, Elena pointed to a small area near the upper right corner of the frame. "There. Do you see that?" A faint luminescence appeared in the image, almost like a mist with a subtle bluish tint. It wasn't bright, but against the dark background of the coffin interior, it was definitely there. For exactly 17 minutes the glow persisted, moving slowly in a circular pattern before fading completely. "That's—" Raj searched for words. "That's not something I can explain with standard decomposition models." By afternoon, the entire team had gathered to review the findings. Tom, their technology expert, had spent hours testing duplicate equipment in the lab to rule out camera malfunctions or sensor errors. "Everything checks out," he reported, looking both confused and intrigued. "The cameras are working exactly as designed. Whatever you're seeing is really happening in there." Lisa, their microbiologist, had a different perspective. "Certain bacteria can produce bioluminescence under specific conditions, but I've never seen a documented case in human decomposition with this specific pattern or timing." Elena stood up and paced the length of the lab, thinking. "We need more data. Are we seeing similar patterns in the other subjects?" Raj shook his head. "Not in Subject 2. I haven't checked Subject 3 yet." "Do that now," Elena said. "And let's set up additional monitoring. I want spectral analysis of that luminescence, and if possible, more detailed temperature mapping of the entire space." The team worked late, into the evening, their initial confusion gradually giving way to the exhilaration of scientific mystery. This was exactly why they had started the project, to discover the unknown. By the end of the week, they had confirmed similar phenomena in Subject 3, the body of a 67-year-old former nurse named Maria Gonzalez, though with slightly different timing and intensity. Subject 2, a 78-year-old retired postal worker named James Wilson, showed no unusual readings at all. "What's different about Subjects 1 and 3? Elena asked during their Friday team meeting. "Why them and not Subject 2? Lisa flipped through her notes. "Different microbiome profiles, for one thing. Mr. Chen and Ms. Gonzalez both had courses of broad-spectrum antibiotics in the months before their deaths. Mr. Wilson didn't. Different soil composition in their plots?" Raj suggested. Tom shook his head. "We controlled for that. All three are in nearly identical soil conditions within our research area." The discussion continued for hours, each team member contributing theories from their area of expertise. They agreed to modify their monitoring protocols and add additional sensors to capture more data about the phenomena. What none of them had anticipated was that their research would soon face challenges from outside the scientific community. The following Monday morning, Elena arrived at the university to find Professor Chen waiting outside her lab, his expression grim. "We have a situation," he said without preamble. "Someone on the ethics committee talked about your project at a dinner party. Word got out, and it's spreading on social media." Elena felt a knot form in her stomach. "How bad is it?" "Bad enough. There's a group of about 30 protesters gathered outside the administration building right now. They're saying we're desecrating the dead. The university president has called an emergency meeting. The meeting was tense, with university administrators clearly concerned about the public relations nightmare unfolding." Elena defended her research vigorously, emphasizing the scientific protocols, the consent of the subjects and their families, and the potential value of their discoveries. "We're seeing phenomena that have never been documented before," she explained. "This could revolutionize our understanding of the post-mortem process." "The public doesn't care about post-mortem processes," the university's PR director countered. "They hear cameras and coffins and react emotionally." By the end of the meeting, Elena had received tentative continued support, but with conditions. They would need to prepare a public statement, meet with concerned community members, and provide more frequent updates to the ethics committee. The protests outside grew over the next few days, with signs reading, "Let the dead rest in peace," and "Science has gone too far." Local news vans parked at the edge of campus, hoping for interviews with anyone involved. Elena refused all interview requests, focusing instead on the research that was becoming more fascinating by the day. The team had enhanced their monitoring systems and were capturing more detailed data on the mysterious phenomena. Then came another unexpected development. An email appeared in Elena's inbox from a Dr. Hiroshi Tanaka at Kyoto University. "Dr. Reeves, I have been following reports about your research with great interest. My team conducted similar experiments 3 years ago, though with less sophisticated monitoring equipment. We observed comparable anomalies, but did not publish our findings. Due to concerns about professional reputation, I would be very interested in comparing data if you are willing. Respectfully, Dr. Hiroshi Tanaka." Elena stared at the screen, her heart racing. This was the first external validation that what they were seeing might be a genuine scientific phenomenon, not just equipment errors or wishful thinking. More emails followed in the coming days. A researcher from Argentina, another from South Africa, and a team from Finland, all claiming to have observed unusual phenomena in controlled decomposition studies, all having kept their findings quiet for fear of ridicule. "We're not alone," Elena told her team, sharing the emails. "These observations have been made before, just never properly documented or published." The controversy outside their lab doors seemed less important now. They were on the verge of something significant, a pattern observed across different continents, different cultures, different research protocols, all pointing to the same unexpected conclusion. There was something happening during decomposition that current science couldn't explain. In her private research journal that night, Elena wrote, "Day 94. What began as an investigation into decomposition processes has become something far more profound. We stand at the edge of a new frontier in understanding the physical processes that follow death. The patterns we're observing suggest organized energy transformations that no current model can explain. Despite the public controversy, we must continue. Some of the greatest scientific discoveries throughout history faced initial resistance and skepticism. What matters is the truth, wherever it leads us." What she didn't write, what she barely allowed herself to think, was the question that kept her awake at night. What if death wasn't the end of physical processes, but the beginning of something else entirely? And what would the cameras reveal? Next, the university campus had finally quieted as winter settled in. 6 months had passed since the beginning of Elena's controversial experiment, and the initial protests had dwindled to occasional strongly worded letters to the university president. In the research lab, however, the energy was anything but quiet. "I'm telling you, these are not random fluctuations," Raj insisted, pointing to the latest data set displayed on the main screen. "Look at the pattern. It's almost rhythmic." Elena nodded slowly, her eyes fixed on the waveforms. The phenomena they had first observed 3 months ago had not only continued, but evolved. The temperature drops and electromagnetic pulses now followed a complex but recognizable pattern, like a very slow heartbeat with additional smaller pulses between the main ones. The light emissions have changed too, Lisa added, bringing up the visual feed from Mr. Chen's coffin. The faint luminescence they had observed earlier now formed distinct patterns, tendrils of bluish light that moved with apparent purpose, sometimes concentrating in one area before dispersing and reforming elsewhere. We need outside perspective, Elena decided. This is beyond our collective expertise. The team had been corresponding with the other researchers who had contacted them, sharing anonymized data and comparing notes. But Elena felt they needed someone who could look at their findings from a completely different scientific angle. 2 days later, Dr. Prisha Kapoor arrived at the lab. A quantum physicist with expertise in energy states and wave functions, she had been intrigued by the description of their observations. "Thank you for coming all this way," Elena said, showing her into the lab. "We've prepared all the data for your review." Dr. Kapoor, a woman in her 50s with keen eyes and an air of focused intensity, nodded. "Let's see what you've got." For hours, the physicist reviewed their findings in silence, occasionally asking for additional data or clarification about their methods. The team tried to continue their work, but everyone kept glancing toward Dr. Kapoor, anxious for her assessment. Finally, she looked up. "This is remarkable," she said simply. "You believe our observations are valid?" Elena asked. "More than valid. They're potentially revolutionary." Dr. Kapoor stood and walked to the main screen. "May I?" Elena nodded, and the physicist began pulling up different datasets, arranging them in new configurations. "What you're observing," Dr. Kapoor explained, "appears to be consistent with quantum coherence, a state where particles become connected and act as a single system. But it's occurring at a macroscopic level, which is extremely unusual outside of laboratory conditions." "In plain English?" Tom asked. Dr. Kapoor smiled slightly. "In plain English, you're observing evidence that some form of organized energy exists. Within these remains behaving according to quantum principles rather than classical physics." A heavy silence fell over the room as the implication sank in. "Are you suggesting—" Raj began, then hesitated. "I'm not suggesting anything metaphysical," Dr. Kapoor clarified quickly. "I'm simply stating that there are energy patterns here that don't match our current understanding of what happens after death. The human body is essentially a complex bioelectric system in life. What you're documenting suggests that some form of electrical or quantum activity continues in an organized fashion after clinical death." Elena felt a chill run down her spine. Could this explain the folklore and myths about spirits or ghosts? People sensing electrical fields or quantum effects they couldn't explain? "Perhaps," Dr. Kapoor said cautiously. "But I'd prefer to stick to what we can measure. And what you're measuring here is fascinating enough without speculation." Over the next few days, Dr. Kapoor worked with the team to design enhanced monitoring protocols. They added quantum sensors normally used in physics laboratories and recalibrated their existing equipment to capture more subtle variations. When the new data began coming in, even the cautious physicist seemed stunned. "The coherence patterns are becoming more complex over time," she noted, examining the readings from Mr. Chen's monitors, now in their 6th month. "It's almost as if they're learning." "Learning what?" Lisa asked. "How to organize energy more efficiently, perhaps. Look at the difference between month 1 and month 6. On screen, they could see that what had started as simple pulses had evolved into intricate patterns with multiple harmonics and resonances." "And what about the visual phenomena?" Elena asked. Tom brought up the enhanced visual feed. The luminescence was now visible even without infrared, a faint but unmistakable blue glow that moved in patterns matching the energy readings. "I believe what you're seeing is biophoton emission," Dr. Kapoor explained. "Living cells emit very weak light as part of their normal functioning. What's unusual is seeing this level of organized photon emission in tissue that's no longer living by clinical definitions." Could microorganisms be causing this, Lisa wondered? We know bacteria communicate through chemical signals. Could they also use light or electrical fields? Possibly, but not in these patterns, Dr. Kapoor said. These are too complex and too coherent for simple bacterial communication. As the team worked to understand their findings, Elena made a difficult decision. Despite the risk of professional ridicule, they needed to share at least some of their observations with the wider scientific community. She carefully prepared a preliminary paper, focusing on the most measurable and verifiable aspects of their discovery. With input from Dr. Kapoor and approval from the university's research committee, she submitted it to the Journal of Experimental Biology. The response was swift and harsh. The paper was rejected within days, with comments ranging from skepticism to outright accusations of fraudulent research. I expected this, Elena told her disappointed team. We're challenging fundamental assumptions. That never goes smoothly. What she hadn't expected was a phone call from Dr. Victor Reynolds, the editor of Quantum Frontiers, a respected journal known for publishing boundary-pushing research. Your paper crossed my desk, he said without preamble when Elena answered. A colleague at Jeeb shared it with me. I'd like to see your raw data. Elena hesitated. Our findings are controversial. The most important findings usually are, Dr. Reynolds replied. I'm not promising publication, but I am promising a fair review. Within a week, Elena had sent their data to Dr. Reynolds and a panel of reviewers he had assembled, including experts in biophysics, quantum mechanics, and forensic science. The team tried to continue their work while waiting for a response, but the tension was palpable. Everything they had worked for, their professional reputations, the future of their research, all hung in the balance. Then, on a snowy afternoon in February, exactly 6 months and 2 weeks into their experiment, something happened that changed everything. The monitoring equipment for Ms. Gonzalez's coffin began showing unprecedented activity. The energy readings spiked to levels they hadn't seen before, and the visual feed showed brilliant pulses of blue-white light organizing into complex, almost geometric patterns. What's happening? Elena asked, as the team gathered around the monitors in alarm. The quantum coherence is intensifying, Dr. Kapoor, who had stayed on as a consultant, observed with quiet amazement. It's as if all the separate energy patterns are synchronizing. For 23 minutes, they watched in stunned silence as the light display continued, the patterns becoming increasingly organized until they formed what looked almost like a web or network of interconnected nodes. And then, as suddenly as it had begun, the activity subsided, returning to the low-level patterns they had been observing for months. Did we just witness some kind of peak event? Raj wondered. I think, Dr. Kapoor said slowly, we just documented the birth of something entirely new. That evening, as Elena was documenting the day's extraordinary observations, her phone rang. It was Dr. Reynolds from Quantum Frontiers. We've reviewed your data, he said, his voice tight with what sounded like carefully controlled excitement. My team has reached a unanimous conclusion. Elena held her breath. We're not only accepting your paper, he continued. We're making it the cover feature for our next issue. Your team has documented something that has never been properly recorded before. This will change how we understand death itself. Elena sat down hard in her chair, overwhelmed. There's more, Dr. Reynolds added. Since your initial submission, have you observed any large-scale synchronization events? Any major spikes in the coherence patterns? Yes, Elena whispered. Today? Actually, how did you know? Because 3 other research teams around the world have reported similar observations within the past 24 hours. Whatever you're documenting, Dr. Reeves, it isn't isolated. It's happening globally, and you're at the forefront of understanding it. As she hung up the phone, Elena looked at the monitors, still displaying the aftermath of the synchronization event. For the first time, she allowed herself to fully consider the implications of what they were discovering. Death, it seemed, might not be an ending, but a transformation, not in any spiritual or religious sense, but in a measurable, physical way that science was only beginning to comprehend. And their cameras, placed as an act of scientific curiosity, had captured the first clear evidence of this transformation. Whatever was happening inside those coffins wasn't just changing their understanding of death. It was about to change humanity's view of life itself. News of Elena's research spread like wildfire through the scientific community after Quantum Frontiers published their paper. What had begun as a controversial experiment viewed with skepticism was now the center of intense scientific interest. Their lab, once quiet, except for the steady hum of equipment, was now bustling with activity as researchers from around the world came to observe their work. "I never expected this kind of response," Elena admitted to Raj as they watched a team from Germany setting up additional monitoring equipment beside their own. "6 months ago, people were protesting outside the university. Now we can barely keep up with collaboration requests." "That's how science works," Raj replied with a small smile. "First, they think you're crazy, then they can't get enough of you." The university, sensing the shifting winds, had not only renewed their funding, but doubled it. They'd been moved to a larger laboratory with state-of-the-art equipment, and Professor Chen, who had once been cautious about supporting them, now proudly introduced Elena as the researcher who is redefining our understanding of death itself. But the most significant change wasn't in their professional standing. It was in what they were discovering through their enhanced monitoring systems. Dr. Kapoor had assembled a team of quantum physicists who worked alongside Elena's original researchers. Together, they had developed new sensors capable of detecting quantum entanglement, the mysterious connection between particles that Einstein had once called spooky action at a distance. "Look at this," Dr. Kapoor said one morning, pointing to the latest readings from Mr. Chen's coffin now in its 9th month of monitoring. "The quantum coherence isn't just maintaining itself, it's expanding." Elena leaned closer to examine the data. "Expanding how?" "It's establishing connections with the surrounding soil microbiome," Lisa explained, joining them at the monitor. "Remember those strange readings we couldn't account for? It turns out the energy patterns are extending beyond the remains themselves." The implications were staggering. What they had initially observed as simple temperature fluctuations and electromagnetic pulses had evolved into a complex network of quantum connections that extended through the soil and appeared to be communicating with microorganisms in the surrounding environment. "It's like watching the development of a new nervous system," Tom said, bringing up the visual feed. On screen, the blue luminescence they had documented for months now formed intricate branching patterns reminiscent of neurons, extending outward from the remains in all directions. "But what exactly are we looking at?" Elena wondered aloud. "Is this some form of energy that was always present in decomposition but we never had the tools to detect it? Or is it something that's actually new?" Dr. Kapoor, always cautious in her assessments, considered this. "I believe what we're observing is an emergent phenomenon. The individual components, bacteria, fungi, the remaining cellular structures, soil microorganisms, are interacting in ways that create something greater than the sum of its parts. In physics, we see this in superconductors, Bose-Einstein condensates, and other quantum systems. But those systems require extreme conditions," Raj pointed out. "Near absolute zero temperatures or perfect laboratory environments. How could this happen in ordinary soil?" "That," Dr. Kapoor said, "is the billion-dollar question." The answer began to emerge when they compared data across all 3 subjects. James Wilson, whose coffin had initially shown no unusual activity, had finally begun displaying similar patterns in his 7th month. Meanwhile, David Chen and Maria Gonzalez had progressed to what the team now called Stage 3, highly organized quantum networks extending up to 2 meters from their coffins. "The timeline is different for each subject," Elena noted during their weekly analysis meeting. "But the progression follows the same pattern." Lisa, who had been diving deep into the microbiological aspects, shared her latest findings. "I've identified a previously unknown class of microorganisms that appear at exactly the same time the quantum effects begin. They're unlike anything in our current taxonomic systems, part bacteria, part fungi, but with some characteristics of both and neither." She brought up microscope images on the main screen. The organisms looked almost crystalline, with geometric structures that seemed too regular, too organized to be natural, And here's the truly strange part, she continued. They appear to be using quantum entanglement to communicate. Not chemical signals like normal microbes, but actual quantum information transfer. That shouldn't be possible in a warm, wet environment like soil, Dr. Kapoor said, frowning at the images. And yet we have measurable proof that it is happening, Elena replied. The discovery of these unusual microorganisms shifted their research in a new direction. Were these strange microbes causing the quantum effects, or were they a result of them? Were they present in all decomposition but had simply never been detected before, or were they something entirely new? To answer these questions, the team set up a controlled experiment. They took soil samples from around the 3 monitored coffins and compared them with samples from traditional graves of similar age and soil composition. The results were definitive. The unusual microorganisms were present only in the soil around their research subjects, and only after the quantum effects had been detected. They're not causing the phenomenon, Lisa concluded. They're being created by it. This revelation led to an even more astonishing hypothesis. What if death wasn't simply an end, but a transformation of biological energy into something new? What if the human body, after death, became an incubator for an entirely different form of life? One that operated according to quantum principles rather than traditional biology? That's a bold claim, Professor Chen cautioned when Elena shared their latest findings with the University Oversight Committee. You're essentially suggesting a new domain of life. The evidence points that way, Elena replied. We've documented a progression that's consistent across all subjects, leading to the emergence of organisms that don't fit into any known category. The committee, once skeptical, now listened with rapt attention as Elena continued. What we're observing isn't the continuation of human consciousness or anything spiritual, she clarified. It's the reorganization of energy and matter into a new form, a form that uses quantum mechanics as its fundamental operating system rather than traditional biochemistry. As word of their findings spread beyond scientific circles, public interest exploded. News outlets around the world picked up the story with headlines ranging from sensationalist, "Scientists discover life after death," to more measured, "New form of microbial life discovered in decomposition study." Elena and her team found themselves thrust into the public spotlight, trying to explain complex quantum biology to reporters who often misunderstood or oversimplified their findings. No, we haven't discovered the human soul, Elena patiently explained during one television interview. What we've found is evidence that the energy and matter that make up the human body don't simply dissipate after death. They reorganize into something new, something that operates according to different physical principles than living organisms. But isn't that essentially what many religions have claimed for centuries, the interviewer pressed, that something continues after death? We're scientists, not theologians, Elena replied carefully. What we can say with certainty is that we've documented a physical process that hasn't been properly observed before. How people interpret that through their own belief systems is beyond our research. Back in the lab, away from the cameras and public speculation, the team continued their meticulous documentation. The phenomena had now reached what they called Stage 4 in both Mr. Chen and Ms. Gonzalez, a phase where the quantum network had become so extensive that it connected with plant roots and soil bacteria up to 5 meters from the original remains. It's almost like watching the development of a new ecosystem, Lisa observed, examining soil samples under her microscope. These microorganisms are forming symbiotic relationships with traditional bacteria and fungi. Dr. Kapoor, analyzing the latest quantum readings, made an even more startling observation. The quantum information processing capacity of these networks has reached a level comparable to simple neural networks. They're not just existing, they're computing. Computing? What? Raj asked, looking up from his own work. That, Dr. Kapoor said, is something we haven't figured out yet. As Elena recorded their latest findings in her research journal that night, she couldn't help but feel they were standing at the threshold of a revolution in human knowledge. What had begun as a straightforward study of decomposition had led them to discover what might be an entirely new domain of life. one that existed in the boundary between the quantum and classical worlds. Day 270, she wrote. We now have conclusive evidence that death is not an endpoint but a transition. The human body, after clinical death, becomes the foundation for a new form of organized energy that operates according to quantum principles. These quantum networks create novel microorganisms with no known taxonomic classification. Whether this process has always occurred undetected or is something new in evolutionary terms remains unclear. What is clear is that our understanding of the boundary between life and death will never be the same. What she didn't write, what she barely allowed herself to consider, was the question that now kept her awake at night. If this quantum network continued to grow in complexity, what might it eventually become? 1 year after placing the first camera in David Chen's coffin, Elena stood at the podium of the International Scientific Congress in Geneva. The Grand Hall was packed with over 1,000 scientists, journalists, and dignitaries from around the world. As she looked out at the sea of faces, she couldn't help but think of how far they'd come. A year ago, she began, her voice steady despite her nerves. Our team set out to document the physical process of decomposition. What we discovered, instead, was a new chapter in our understanding of life itself. Behind her, a large screen displayed time-lapse imagery from their year-long monitoring, the gradual appearance of the blue luminescence, its evolution into complex patterns, and finally the development of the quantum networks that had captured the world's imagination. What our cameras revealed, she continued, was not the end of a physical process, but the beginning of a transformation. The human body, after clinical death, becomes the foundation for a new form of organized quantum activity that ultimately leads to the emergence of previously undocumented microorganisms. She clicked to the next slide, showing electron microscope images of the crystalline microbes they had discovered. We've named this new class of organisms quantum transitionals and are QTs for short. They represent what may be an entirely new domain of life, one that exists at the boundary between quantum and classical physics. In the front row, Elena could see her team watching with pride. Raj, who had been with her from the beginning. Lisa, whose microbiological expertise had been crucial to understanding the new organisms. Tom, whose camera systems had made everything possible. And Dr. Kapoor, whose insights into quantum physics had helped them make sense of what they were seeing. But the significance of our findings goes beyond taxonomy, Elena continued. These organisms appear to be part of a natural recycling system that we've never observed before, one that operates at the quantum level, converting the energy and information contained in human cells into new forms of life. As she spoke, Elena recalled the moment, 3 months earlier, when they had made their final breakthrough. It had been a quiet Tuesday afternoon when Lisa had rushed into her office, barely able to contain her excitement. "You need to see this," she had said, pulling Elena toward the lab. "We've figured out what the quantum networks are doing." In the lab, the entire team had gathered around a complex 3D model showing the activity of the quantum network surrounding all 3 research subjects now in their 9th month of monitoring. "We've been looking at this all wrong," Lisa had explained. "We thought the networks were just communicating, but they're doing something much more sophisticated. They're mapping and preserving the molecular structures from the original remains." Gair. Kapoor had nodded in agreement. "It's like a molecular library. The quantum network is recording the exact arrangement of molecules from the human tissues before they decompose completely." "But why?" Elena had asked. "What's the purpose?" Tom had pointed to another screen showing microscopic images of soil from around Mr. Chen's coffin. "Look at the new organisms growing in the soil. Their internal structures contain molecular patterns that match specific tissues from Mr. Chen's remains. They're preserving the information," Raj had realized. "Not consciousness or memory, but the actual biological information, the molecular blueprints that made that person unique." That discovery had changed everything. What they were witnessing wasn't just an interesting quirk of physics or a new type of microbe. It was a fundamental natural process that had gone undetected throughout human history, a quantum-level recycling system that preserved the molecular information of organisms after death and incorporated it into new forms of life. Now, standing before the scientific community, Elena explained this final piece of the puzzle. The quantum networks we observed serve a specific purpose. They act as a molecular memory system, preserving the unique biological information from the deceased and transferring it into new organisms, not as consciousness or identity, but as molecular patterns and structures that influence the development of future life in that ecosystem. She paused, letting the implications sink in. In essence, we've discovered that death is not the end of our physical influence on the world. The information contained in our bodies, the unique arrangement of molecules that makes each person distinct, continues to shape the life that comes after us, at a level we never knew existed. The hall was completely silent as she spoke, hundreds of scientists trying to absorb the paradigm-shifting implications of what she was describing. This discovery has potential applications that extend far beyond forensic science, Elena continued. Early trials suggest that understanding these quantum transitional processes could lead to breakthroughs in environmental remediation, as the QT organisms show remarkable abilities to break down pollutants and restore damaged soil. She clicked to a slide showing laboratory results from their newest experiments. QT organisms introduced to soil contaminated with petroleum products reduced toxic compounds by 89% within 30 days, far more efficient than any current bioremediation technique. Similar results were observed with heavy metals and synthetic chemicals previously considered non-biodegradable. In the months leading up to the conference, their research had expanded beyond the original Coffin cameras. With funding from environmental agencies and research institutions worldwide, they had begun exploring the practical applications of their discovery. We've also identified potential medical applications, Elena explained. The quantum communication methods used by these organisms operate at speeds and efficiencies that far exceed conventional biochemical processes. Understanding these mechanisms could transform our approach to everything from drug delivery to tissue regeneration. What she didn't mention from the podium, though it was covered in their published papers, was perhaps the most profound implication of all. Evidence suggested that these quantum processes had been occurring throughout human history and across all living organisms. Every person who had ever lived had in death contributed to this invisible quantum legacy, their molecular information preserved and incorporated into new forms of life. As Elena concluded her presentation, she shared a final image, a time lapse, showing plants growing in soil enriched with QT organisms. The plants grew nearly twice as fast as the control group, with more vibrant coloration and greater resistance to disease. What our cameras revealed in those coffins was just the beginning, she said. We've discovered a missing link in our understanding of the cycle of life, a quantum dimension to death and renewal that has always been there, unobserved until now. The applause that followed was thunderous, but for Elena, the most meaningful moment came after the presentation, when an elderly woman approached her quietly. "My husband was a biology teacher," the woman said. "He died last year and donated his body to science. He always said that death was just another form of transformation. I wonder now if he somehow knew." With a jolt, Elena realized this must be Lin Chen, David Chen's widow. "Your husband's contribution to science was immeasurable," she said, taking the woman's hand. "He was right. Death is a transformation, and because of him, we now understand how profound that transformation really is." Later that evening, as the team celebrated in a small cafe overlooking Lake Geneva, they reflected on the journey that had brought them here. "When we placed that first camera," Raj said, raising his glass in a toast, "we thought we were just documenting decomposition. Instead, we discovered that death isn't an ending at all." "To David Chen, Maria Gonzalez, and James Wilson," Elena added, raising her own glass. "Their final contribution to science changed our understanding of life itself." As the team celebrated across the globe, countless organisms lived and died, their molecular information preserved and passed on through quantum networks that had always existed, invisible to human eyes until a simple camera in a coffin revealed their presence. The distinction between life and death, it turned out, was not a hard line but a transformation, a passage of energy and information from one form to another, in an endless cycle that connected all living things at the quantum level. It was not the continuation of consciousness that many had hoped for when pondering what lies beyond death, but it was something perhaps more profound, the discovery that, in a very real and measurable way, the physical essence of every person who had ever lived continued to influence the world long after they were gone, their molecular legacy woven into the fabric of life itself through quantum connections that transcended our previous understanding of death. The cameras had revealed not just what happened in a coffin, but a new dimension of existence that had been there all along, waiting to be discovered.